starting this circuit, we're instructed to find the current I and the voltage V with source transformation. What's worth noting from the beginning is the resistance across this resistor is unknown, yet its voltage is equivalent to 4 multiplied by the current I. In these situations, it's usually best to start from the left side and simplify left to right. With that in mind, I suggest we begin by transforming the 18 volts and 3 ohm resistor into its equivalent circuit with an independent current source with the same resistor, though they will be connected in parallel. Before you transform this side of the circuit, I recommend that you firstly circle it for visual clarification, and then calculate the current source with Ohm's law, which again is V equals IR, yet if you rearrange for I, it's I equals V divided by R, which in this case is 18 volts divided by 3 ohms. Assuming you remember basic math, 18 divided by 3 is 6. And the associated units in this case are amperes. After redrawing the circuit, though you might not initially notice it, all 4 of these elements are connected in parallel at this top node and this bottom node, which means that these 2 resistors are connected in parallel, and we can calculate the parallel equivalent of them, and both of these independent current sources, which are flowing into this node, can be added. We can find the value of the combined currents simply by adding them, which would be 6 amperes plus 4 amperes, which equals 10 amperes. Next, we can find the resistance equivalent of these 2 resistors connected in parallel with the product over sum equation, which would be 3 ohms multiplied by 6 ohms divided by their sum, which is 3 plus 6. 3 multiplied by 6 is 18. 3 plus 6 is 9. And 18 divided by 9 is 2. And the associated unit, again, is the ohm. This is the redrawn circuit after the transformation, and you'll notice that it has been substantially condensed. Usually at this point, you could apply current division to calculate I. However, in this case, that's impermissible because the value of this resistor is unknown. For that reason, I recommend that we perform another transformation on this 10 amperes in parallel with 2 ohms, and then we can combine that resistor with the 4 ohms. Again, before we redraw the circuit, I recommend that we calculate the voltage, which again is governed by Ohm's law. V equals IR. In this case, the I is 10 amperes, and the R that we calculated earlier is 2 ohms. Therefore, the voltage will be 20 volts. The resistance will stay the same, yet it will be connected in series with the 20 volt source. After redrawing the circuit, you should immediately notice that the 2 and the 4 ohm resistor are connected in series. Therefore, we can immediately add them to create a 6 ohm resistor. The circuit is now primed to apply KVL. So first we will designate the direction in which we will apply it, and we will write the equation. KVL states that the sum of the voltages in any loop in a circuit equals 0. So starting from the negative 20 volts, because the arrow is entering through the negative terminal first, plus 6 multiplied by the current, which is the same current flowing through this loop, which would be 6I, plus the voltage across this resistor, which is defined 4 multiplied by I. And according to KVL, the sum of the voltages equals 0. We can then add the 6 and the 4, which equals 10I equals 0. Then we can add 20 to both sides. And if we divide both sides by 10, 20 divided by 10 equals 2. And finally, we can very easily solve for the voltage by substituting 2 for I, which is then 4 multiplied by 2, which equals 8 volts. Always remember to write the units beside them.